Hello everyone, welcome to the lecture series of Building Estimate, how to calculate the quantities of different item of works. So from now on, we are going to learn one of the most important portion of the subject, that is quantity calculation, and which is known as building estimate. Students, till now you have learned about tenders and contract, introduction to building estimate, rate analysis, and mode of measurement. From now on, we are going to discuss about building estimate, and in that topic, we are going to cover up that how to calculate the quantities of different item of works. So, we are going to learn introduction to building estimate, measurement sheet, abstract sheet, types of structures, methods of calculating the quantities, and then we are going to start our first method of quantity calculation, which is Centreline Method. So we are going to cover up 6 topics in this session. So starting our session with introduction to building estimate. To prepare a detailed estimate of any structure, it is divided into the various parts such as excavation for foundation, concrete in foundation, earthwork in filling, masonry in foundation, masonry in superstructure, RCC work, painting, flooring, plastering, woodwork for doors and windows, etc. Yes, you can divide the structure in as much as item you want. From the excavation to the lock and key of a house, that is, everything can be measured in some of the quantities in different units. So once you divide your entire structure into various components like this, then the quantities are being worked out from plan, elevation, and section of the structure. Yes, first you need to decide that what quantity you want to calculate. Then you have to work out the dimensions from plan, elevation, and section. And to calculate the quantities, measurement sheets are used. So let us recall that what we have learned in the session of introduction to building estimate. We have learned that to prepare an estimate, what are the data required? Drawings. Drawings, that means plan, elevation, and section. Because from plan, elevation, and section, you are going to get length, width, and height or the depth of the component. For an example, if we are talking about the excavation quantity, the plan will give you the length and width, and the section will give you the depth of the excavation. And these quantities are being written in measurement sheet to calculate the quantity. So moving forward, let us understand that what is measurement sheet and how it is being prepared. So as you can see, measurement sheet looks like this kind of tabular format. In this table, I have prepared several columns such as item number, item description, numbers, length, width, height or depth, and quantity. Yes, this much are column you have to prepare in a tabular format. So that is what measurement sheet looks like. That the first column is item number. For an example, if you are working out for the quantity of a bungalow, there are hundreds of items. So you have to give the item number 1, 2, 3 and so on. Then there is item description. So item description is the name of the component of which you are quantity for working out. So there is so if you are working out for the excavation, you write excavation for foundation, and if you are working out for the external plaster, you write plaster work for external side, and so on. So that is item description. Now there is next column is numbers. Numbers is the column which is being used for similar kind of works. For an example, if you are calculating the quantity for the plaster work and have two walls are having same dimension, so don't write individually for that two walls, you write just number 2 in the column of numbers. So that quantity will be calculated 2 times for that wall. So I hope we are clear about the numbers. Then there is L, B, H or depth. So that is a common, that length, width and height or depth. But here students mind well that length, width and height or depth should be in same unit. Yes, all the 3 units should be same, either in meter, either in mm, either in feet. All of these should be same. You cannot multiply having a length in meter and width in feet. I hope that is a point of common sense. So do not make such mistake while calculating. You have to put unit all of the same for L, B and H. Now to get the quantity, you need to multiply numbers into length, into width, into height. So you'll get your quantity. So that is how a measurement sheet is prepared. Now, after the measurement sheet is being prepared, you need to prepare an abstract sheet. This measurement sheet and abstract sheet you have already learned into the sessions of building estimate. So now moving forward with the abstract sheet. The cost under item of work is calculated from the quantities of the measurement sheet and the workable rates from the market, and the total cost is worked out in a prescribed format that is known as abstract sheet. Yes, this is a general formal definition of abstract sheet, that when you multiply your quantities with the workable rates or the market rates in a prescribed format, that becomes your abstract sheet. A percentage of 3 to 5% is generally provided in the abstract sheet for the contingencies or for the petty expenses or for the unforeseen expenses which are bound to happen during the construction, such as change in design, change in rates, etc. A percentage of 1.5% to 2% is generally added to meet the expenditure of work charge establishment. And the grand total of all of this, the original cost plus 3 to 5% of contingencies and 1.5% to 2% of work charge establishment, gives the total estimate or the total cost of the work. So this is how an abstract sheet is being prepared. Now let us look at the format of the abstract sheet. So as you can see, it is the format of the abstract sheet having 6 columns such as item number, item description, quantity, rate, per unit and the total amount. Yes, having 6 columns. So first is item number. This item number is the same as you have written in the measurement sheet. Then there is an item description. Again, that item description is the same which you have written in the measurement sheet. Then there comes the quantity. In this column, you have to write the quantity which you have already derived in the measurement sheet. Then there is the column of the rate. In the column of the rate, you have to write down the rate of particular item of work. For an example, if you are working out the rate for excavation, so you have to write the quantity from the measurement sheet and you have to put the rate in the column of rate. Then there is the column of per unit. Per unit, that means the unit of particular item of work, per cubic meter, per square foot and so and so. Then you have to multiply the rate with the quantities so you can get the amount. So this is how you will prepare an abstract sheet. And at last we will add 3 to 5% contingencies and 1.5% to 2% of work charge establishment. And the grand total of all of this will become the detail estimate or the total estimate of the work. So I hope we are clear up to this point. Now, moving forward, let us look at the types of structures. So as you know, there are basically two types of structure in our civil engineering: frame structure and load bearing structure. So talking about the frame structures are more stable and reliable in the earthquake. Frame structures makes the structure more flexible. The load transfer mechanism in the frame structure is slab to beam, beam to column, and column to foundation. Now, talking about the load bearing structure, the load bearing structure, the load bearing masonry are constructed with the help of brick, stone, or the concrete bricks, etc. The load bearing structure transfer the load to the foundation in following manner: slab to wall and wall to foundation. So in load bearing structure, the load carrying component is the walls. So I hope we are clear about what is load bearing structure and what is frame structure. So the quantity estimation you are going to learn in this semester is more about the load bearing structure. Also, you are going to learn about the RCC calculation, but more or less the numericals are based on load bearing structure. So now let us quickly see what are the methods for calculating the quantities. So here are the methods for calculating the quantities. There are three methods which we are going to use. That first is Centreline method. The second is long wall and short wall method, which is also known as in-to-in and out-to-out method. And the third is crossing method. But as a part of your course, we are only going to learn two methods: Centreline method and long wall and short wall method. So before we move forward in our session and we start understanding the first method, which is Centreline, let us just quickly revise that what we have learned in today's session. So we have started with the introduction to the building estimate, in which we have seen that you need to divide the entire structure into the components such as excavation, PCC, then masonry in foundation, earth filling, brickwork in superstructure, RCC slab, painting, flooring, plastering, etc. Once you divide the entire structure into the component, then the dimensions are being worked out from plan, elevation and section. Then when you get the dimension, you prepare a measurement sheet. Then we have seen the format of measurement sheet. Once the measurement sheet is being prepared, then you have to prepare the abstract sheet. Now what was abstract sheet? Abstract sheet in which you multiply your quantities with the rates, in which you add 3 to 5% as contingencies and 1.5 to 2% as work charge establishment. And then we have just seen the types of structure: load bearing structure and frame structure, and what are the load transfer mechanism or path of the load transfer in both type of structure. So I hope we are clear up to this point. Now let us start our first method of the discussion, that is Centreline method. In this method, sum, which is total centerline length of all the walls in the drawing, no matter long or short, has to be found out. Yes, that is our first and foremost point of our theoretical concept which we are going to use in our sum, that is in Centreline method, sum, which is total centerline length of all the walls appearing in the drawing, no matter long or short, has to be found out. Find the total length of the centerline of walls having same type, long and short, having same types of foundation and footings, and then find the quantities by multiplying the total centerline length with the breadth and the depth or the height. Yes, once you find out the total centerline length from the drawing, all you need to do is you need to multiply that length with breadth and height from the drawing. It may be bouncing from your head, but please wait till we cover up a simple example. Let us just finish the theoretical concept. I'll explain one brief example so all the fundamentals of Centreline method will be clear to you. So we were discussing that in the total centerline length, you have to calculate the total centerline length of all the walls appearing in the drawing, and then you have to multiply them with breadth and height. In this method, the total centerline length will remain same for the excavation and concreting foundation. Moving forward, this method is a quick but requires special attention and consideration at junctions, meeting points of the cross walls. Yes, this is very easy method, very quickly you can calculate the quantities, but in this method, when there are junctions appearing, you need to be very attentive at that point. The junctions are the meeting points of the cross walls. Now, the centerline length of the wall will be in twin dimensions of the wall plus half width of one wall plus half width of the another side. Yes, if you are talking about a wall, in twin dimension plus half width of another side and half width of another side, that makes a total centerline length. Now, if the wall thickness is same at both the ends, the formula will become total centerline length equals to in twin dimension plus one width of the wall. So that is how you calculate the centerline length of the wall. So now let us look at an example first. So consider this room of having dimensions 4 meter cross 3 meters. Now you might be thinking that in which direction we have to consider 4 meter and in which direction we have to consider 3 meter. So let me tell you that this thing you have already learned in building and town planning, that the first dimension is horizontal dimension and the second dimension is always vertical dimension. So here the 4 meter is for the horizontal direction and the 3 meter is for the vertical direction. So we need to consider 4 meter in horizontal direction and 3 meter in vertical direction. Now the wall thickness is 0.90 on each side of the wall, as you can see in the drawing. Now let us cut a section from the drawing. So cutting out the section AA, we can see that the width of the section is 0.9, which is same as the wall width, and the height of the section is 1.2 meter. So that is our depth. That is 1.2 meter. Now here we need to find out the total centerline length, or let us say we need to calculate the quantity for the excavation. So for the quantity of excavation, first we need to work out the total centerline length. So let us start with our formula. So as you know that centerline length is equals to inner dimension of room plus half thickness of one side plus half thickness of other side. Now here the wall was having same thickness on both the ends, so the centerline length will become inner dimension of the wall plus one width. Now we are calculating in the horizontal direction first. So in twin dimension was 4 meter plus 0.45, 90 was 0.9 was your thickness, so half on another side, 0.45 plus half on another side, 0.45. So 4.9 meter will be the total centerline length in horizontal direction. Same as in the vertical direction, in twin dimension was 3 meter plus 0.45 on another side and plus 0.45 on another side. So that will be 3.9 meter. Here there were two horizontal walls and two vertical walls. So the total centerline length to be multiplied with 2. So 2 times 4.9 and 2 times 3.9, that will give us 17.60 meter. So I hope we are clear up to this point. What we have done? We have done just the total centerline length calculation. So moving forward, as you can see in the drawing, I have highlighted the total centerline length which we have just found out from the formula of the method total centerline length. For rectangular, circular or polygonal buildings having no cross walls, this method is quite simple. But for the buildings having cross walls or partition walls, for every junction of portion or for every junction of partition or the cross walls with the main wall, half weight of the respective item or footing is to be deducted from the total centerline length. Yes, I am repeating again that if your building is having no cross wall or no partition wall, this method is quite simple. But when your building is having a cross wall, you need to deduct half weight from the respective level or from the respective footing per junction, for every junction. Mind well, for every junction you need to deduct the half breadth. So in such cases you have to calculate net centerline length, which is formulated as net centerline length equals to total centerline length minus half into breadth into breadth of continuous wall into number of junctions. Again, I am repeating that it might be bouncing off from your head, but wait till once numerical, all the fundamentals will be clear out. So moving forward, looking at few of the points in connection with the centerline method. The first is, the term junction is used to indicate the meeting point of the cross wall or the partition walls with the main wall. For example, if there is one cross wall, there will be two junctions. At corner, there is no junction formed. Yes, again a point to be remembered, that at corner there is no formation of the junction. So at the four corners of the building, you do not have to consider as a junction. Why? Let us discuss. For rectangular building, there will be no cross walls, so there will be no junctions, and if there is no junction, there is nothing to be deducted from the quantity calculation of the total centerline length. It is due to the fact that the certain portion are taken twice are counterbalanced by the same amount of the portions which are left out at the corner. See this figure. As you can see in this figure, that you can see that while two walls are meeting, there is a common junction which is calculated, but at the same time there is a corner junction which is left out. So if there you are calculating the overlapping, against of that you are lefting this corner out, so it will be balanced. So I hope we are clear about the second point. The breadth indicates the width of an item whose center line is being worked out. For instance, if you are calculating the quantity, or if you are calculating the total centerline length for the excavation or the concrete, the width of the foundation width will be taken of the bottommost part of the section. But if you are calculating for the plinth or the certain up to upper superstructure level, the width will be the corresponding will be equal to the thickness of the wall. So I hope we are clear up to this point. Now moving forward, for a two-room building having one inner cross walls, two junctions will be formed as shown in figure. So as you can see in the figure that there is there is in two room divided by the one partition wall. So there are two junctions being formed known as junction P and junction Q. Now let us calculate the total centerline length for this case. So as you can see, the total centerline length will be 2 times the length of AB, 2 times the length of BC plus 1 centerline length of EF. So as you can see in the figure, the wall AB is similar with wall DC and the wall BC is being similar with the wall AD, and there is one wall in the center, that is EF. So we need to calculate the centerline length of that AB plus BC plus CD plus AD plus EF. So talking about the center to center distance of wall AB. Now here in the question it is given as 9.5. So 2 times the 9.5. The vertical center to center distance is given as 5.5. So 2 times of 5.5 and plus EF. That vertical distance of EF will be the same as of BC. So plus again 5.5. So the total centerline length will be 35.50 meter. Now in this scenario, if the total centerline length is multiplied with the breadth and height, the quantity at the junction P and Q will come twice. So we need to deduct it. Let us see the figure again. As you can see the figure very closely. P and Q in the centerline of wall AB and the centerline of EF. The P is calculating twice, it is double hatched, same as the case of Q. So if we are calculating from the 35.5, this length into the height into width, this point P and point Q will be calculated twice. So we need to deduct it, and as we have learned, when there is a cross wall, we need to deduct half breadth into number of junctions. So here there are two junctions and the breadth, whichever level we are talking about. If we are talking about the excavation, we need to take the breadth of excavation. If we are talking about the superstructure level, we need to take the breadth of superstructure level. So we need to calculate net centerline length. So net centerline length is total centerline length minus half into breadth into number of junction. Now the wall here we are talking about the wall thickness was given 0.9, so breadth is taken as 0.9. So the original total centerline length was 35.5 minus half into number of junctions 2 into breadth 0.9. So we'll get the net centerline length as 34.60 meters. So I hope we are clear when there is one junction one cross wall in the drawing. Moving forward, a greater care has to be taken for the junctions where the walls with different footings are made. For instance, let us consider that main walls are A type and the cross walls are of B type. In such cases, the center line length of type A walls shall be calculated jointly first, and then the center line length of B type of wall shall be worked out. No deduction shall be made while calculating the total center line length of the A type, but while calculating the total center line length of the wall B type, you need to deduct the junction, and for each junction half breadth you need to deduct. So let us consider a scenario. Just what I have read, let us take an example of it. So as you can see in the figure, the main walls are of A type having 0.9 width and cross walls are of having B type having 0.6 width. So main walls PQ, QR, RS, SP are of A type having foundation of 90 cm and cross walls XYs are of B type having foundation of 60 centimeter. To calculate the centerline length of such case, let us see. So beginning with the calculation of total centerline length, as we have discussed, we need to first calculate the total centerline length of A type of wall. Now the A type of wall are at the peripheral. Look at the figure. The A types of wall are at the periphery or at the exterior. So there are two horizontal walls of A type and two vertical walls of A type. Now center to center distance. Here the center to center distance is given directly in the drawing. If not, we have done into in dimension plus width of wall. But here the direct in center to center dimensions are given. For vertical there is 7 meter. So 2 times of 7 meter because there are two vertical walls. Now there are two horizontal walls. 9.5 is the dimension. So 2 times of 9.5. So 2 times of 9 in 9.5 plus 2 times of 7 will give us the total centerline length of A type of wall. And that will be 33 meter. Now let us look at the junctions of A type to B type wall and B type to B type wall. So as you can see, there are 4 junctions between A type to B type wall and there is 1 junction having B type to B type wall. Now let me quickly generalize you the concept of junction. First, we don't need to calculate the junctions at the corner. Then to have a junction, we need to look for two shapes, T and plus. If there is an T or plus in the drawing, that's a junction. For plus, we will calculate as 2 times T. How and why? We'll discuss later. Now, let us calculate the centerline length of B type of wall. So there is one horizontal wall in B type, so 9.5 center to center. And there is one wall of vertical 7 meter center to center. So that will be also added in center line of B type of wall. Minus half width into width of A type of wall into junction minus half of width of B type of wall into number of junction. So we'll get the final quantity as 14.60 meter. So I hope we are clear up to this point. Now as I've told you that how to identify the junctions. So junctions are generally in 2 types of shape, T and plus. For every T junction, half width is deducted and for every plus junction, it is considered as 2 times of T junction. To identify the junction, let us draw a line diagram of the drawing and then we highlight the junctions. So here is the line diagram of our drawing, and to calculate the junction, we are not considering the corners, we are just considering the T and plus shape. So that is how we'll calculate the number of junctions. For plus junction, we'll consider 2 times of T junction. So this is it. That was all about in today's first session. I hope you have learned it very well. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.